So, thank you for coming to this very important event, at least for us, because we are proud to bring all our partners in this wonderful environment that is the Italian pavilion. And this afternoon we will talk with you about the scientific pathway from Torino to Osaka. The title talk about the collaboration between Italian scholars and scholars and the researchers of Japan. And this is something that is really meaningful for us. We are working with Japanese friends. There are a lot of research and also a lot of universities that are intended to produce result, technological innovation with us. I want to leave the floor to our Vice Rector, Alberto Sapora, to give you some words of welcome.
So, good afternoon, ladies and gentlemen. It's an honor for me, as a Vice Rector for International Affairs of Politecnico di Torino, to welcome you at this workshop entitled Scientific Pathways from Torino to Osaka, a cross-cultural collaboration series. Politecnico di Torino is very proud to be the first university in Italy to have a hub, basically a strategic hub here in Japan, in Tokyo, meaning the building of bridges between the two institutions, between Italy and Japan. Over the last years, we have developed fruitful collaboration, strategic collaboration with Japanese university based on mutual respect, common values, and a common vision for scientific innovations. So we believe, actually, that today, with this workshop at Osaka 2025, this event could represent a further step to strengthen our collaborations. And we believe that matching Italian creativity with the Japanese excellence could lead the future for young generation and for society for what concerns research and innovation. Finally, I would like to thank basically the academic partner, and I would like to thank basically people who have worked basically to promote and to create this event. So a special thank basically to the administrative staff of Politecnico di Torino, related especially to the Department of International Affairs and to Communication. And as a Vice Rector of Politecnico di Torino, I hope that this event could promote basically future collaboration between Italy and Japan and between Politecnico di Torino and Japanese University. Thank you very much and enjoy the workshop.
Thank you, Alberto. And now I want to give you a few words about the aim of the workshop. As you can see from the list of our speakers, we will have a presentation that are coming from different universities. We will have Kyoto Institute of Technology, Institute of Science Tokyo, Tohoku University, Osaka University, and that means that this workshop is a symbol of our collaboration network. Obviously, we have so many other universities. Some of you are coming from other universities, so obviously we can't have all of you here, but we want to say through this workshop that we are open, really open. And I want to introduce some few words about collaboration. Our Vice Rector will talk about the hub that we are opening, and I kindly ask to send a video that show the aim of the hub that we open.
POLITO Japan Hub, the first Italian university hub in Japan. Founded in 2023 by Politecnico di Torino, one of the top European technical universities for education, research and technology transfer, POLITO Japan Hub's new office opened in Tokyo in 2025. Its mission? to strengthen the Italy-Japan strategic partnership through research, technology transfer, and education. The hub focuses on cutting-edge research, working with top-level scientific partners to place technological innovation at the service of humanity and lead future development. It promotes mobility for professors and young researchers, encouraging exchange programs between Italy and Japan. Together with Japanese institutions, POLITO Japan Hub participates in competitive project calls, fostering collaborative innovation and shared growth. Japan is a strategic partner for Italy and for the Politecnico di Torino. Both countries face similar challenges: sustainability, a human-centered society, technological innovation, environmental risk management, aging populations, and the protection of cultural heritage. Through this hub, we build international networks, develop new ways of sharing high-tech knowledge, and create opportunities for student exchange. We want to contribute to an interconnected, sustainable, and peaceful world. The hub is an extraordinary opportunity to link ancient cultures like those of Italy and Japan, while simultaneously working on the development of future technologies. POLITO Japan Hub, bridging Italy and Japan, shaping the future through innovation and collaboration.
Okay. I want to add a few words more, talking about our mission. We have mainly three missions. One is education, and this mission will be done according to some strategic vision that we develop in our university, and mainly it will be related to mobility of a student, and really I will talk also about the mobility of researchers. We are very interested also in technology transfer and research, and the idea is to increase again the mobility of professors and the participation on a competitive call that can enable the research activity. The technology transfer also is very important for us because we are a technical university, so we want to involve also industrial partners in our activity, both from Italy and Japan. And finally, reputation. Reputation is very meaningful and powerful, both in Italy and Japan. We are trying to increase our reputation, and also all those events in the frame of Expo 2025 are a very important tool for this. Finally, the Japan Hub structure is made by professors that are coming from all the departments of our university. So I don't want to lose so much time to read all the departments, but those are all the departments that are related to engineering, architecture, design in our environment of research. So I'm sure that you will find a good partner for any proposal of research that you want to have. And again, the number of partners that we just have is very wide. In the last year, we opened some new collaboration, for example, with Kanazawa University or with Chubu University, and many other universities were there before. And so our aim is to keep this network effective as much as possible. Finally, we are trying to build some tools that enable the collaboration. So we are making two groups of professor and researcher. The first we call Japan Hub POLITO community. That is all the professor researchers that are in Politecnico di Torino are working with Japan. And the second group is the Japan Hub Fellow Academy. This academy is made by the professors in Japan that are working with Politecnico Torino. During the opening of the new office in Tokyo 3 days ago, we provide the first 4 certificates of this academy to 4 different professors belonging to 4 different universities. And the message is that this group is open, and we will increase as much as possible in order to have 2 communities that are working together. If you have any proposal, activities, and so on, please use our email address to contact me and all of us, and for sure we will answer you. So that's all from my side, and now let's move to the presentations. And the first couple of speakers will be Professor Specchia from Politecnico di Torino and Professor Sugara from Kyoto Institute of Technology.
Thank you, Quaglia-sensei. This is our first talk, and the title is Converting Waste Heat into Electricity to Power Billions of Sensors. This is a cooperation of POLITO together with Kyoto Institute of Technology, Professor Sugahara here, and that since a couple of years is standing with very interesting results. We are talking about the motivation first. The motivation is how we can power cyber-physical systems or IoT, and so we need power to provide energy to sensors, to transfer data, for transportation, offices, houses, business. But basically what we need, we require high performance, we require energy saving, we require low price and high reliability to make those systems really useful for our needs. And basically, our work is a contribution to future society, and we spend our research and our efforts to develop materials, devices, and processes that are reliable. So first of all, what are thermoelectric materials and what are thermoelectric generators? Basically, we can use specific materials that are able to use the Seebeck effect. So when there's a hot side and a cold side, with specific materials, we are able to create energy. And basically, this is known as Seebeck effect. So we are able to transfer electrons from the hot side to the cold side, and in this way, we are providing energy. And we are able to use this energy. But we need specific materials, that those are semiconductors, and we need N-type and P-type conductors, where basically we are using specific materials to dope other elements and then to add or remove electrons, and then let those materials able to transfer electrons and then to generate electricity. But how we can realize those systems? So we can use, for example, doped bismuth telluride alloys, that when we are doping with specific elements, we can create P and N-type semiconductors. We need also copper, because we need to create the electrodes, and copper has a very high conductivity, and we need specific solders to make all devices together. And in the picture, you can see when we are coupling those materials and we use them, we can create stress, so we need to be very careful in the preparation of those systems, because we could have thermal stress, and then this is linked with a reduction of the efficiency. So when we are realizing those items, we need to minimize the contact resistance and to enhance basically the reliability. And we need flexibility and miniaturization to be able to serve as sensors.
Thank you. Great introduction about the thermoelectronics and our research background. I just a few minutes, few sentences I talk with my presentation. So I'm Toru Sugahara. I was working Kyoto Institute of University. I moved Osaka University to Kyoto Institute of Technology 2022. So I would like to explain again the thermoelectric generator of the operation principle and again. So if you you can see that this is T materials N type. The T material have temperature difference. The electron is diffusion, its opposite side, and have make voltage. So P-type also have a hole and temperature difference, diffusion, and difference voltage is, but it is opposite direction. So these phenomena have a Seebeck, called the Seebeck coefficient. So we are fabricating this kind of device, but this device is a very small voltage. So we have to increase the voltage to make integrate p-n pair is a limited area and a lot of p-n pairs. And this series junction is produce some power, big some power. And performance of the TEG is defined this equation. So you can easily understand the voltage is have to increase, but you reduce the internal resistance. So this is I would like to show how to fabrication the device. So easy to understand. I prepared this movie. So we can integrate the materials, so especially T materials, by using this apparatus almost automatically. So you can see it here. So difficult it is. Okay, just a moment. It is difficult to control but okay, just a moment.
You want to go up?
Oh, okay. I will skip. So not only the small device, but also the large-scale flexible TEG device, we are successful fabrication. So this large-scale device is achieved about 360 microwatt per square centimeter. And small device also 110 microwatt per square centimeter. So it is a small temperature difference at about center side, at about here. Here is a temperature difference of 5 Kelvin. So, and we are focusing the reliability and environmental stability at the bonding interface is here. The bonding interface is located on the bismuth telluride. It is a TE material and electrodes. So this is one of the results of the after and before and after acceleration environmental test. The 250 degrees Celsius, 500 hours. So you can see the before and after is the elemental sorry, the sorry, the element is diffusion is each other, and degradation is here. So we have to understand this kind of mechanism and reduce the degradation. So, and we are recently focusing the contact resistance. I maintained we have to reduce the internal electroresistivity. So we are measuring the accuracy measurement specific contact resistance. So it is can be compared the contact resistance T material and each some some metals. And also, in addition, we are comparing, we are measuring the temperature dependence of the specific contact resistivity. So these results we achieved our research collaboration. Okay, finally.
Thank you. So to conclude, here we are showing our collaboration that started in 2023. So we had several reciprocal visits. So Professor Sugahara spent 4 months as visiting professor in Torino. One of my students spent 6 months working in the Sugahara group, creating the sensors and providing the measurements and the finite element analysis to measure the stress. And I visited 2 times the last year and this year the group to wrap up the work. And the collaboration came up with 2 papers already published and a third one which has been submitted. And we would like to thank our sponsors, in particular the Japanese sponsors for the project, POLITO Japan Hub, and most of all our 2 students, Akihira Katsura and Daniele Mikuchi-san, that basically made most of the work supervised by Professor Sugahara and by me. And with that one, we would like to thank you for your kind attention. ご清聴ありがとうございました。
Grazie la questa attentino.
Thank you.
Thank you so much.
Thank you.
Thank you so much. And now it's time for the next speakers that are Andrea Botta from Politecnico Torino and Daisuke Matsura from Institute of Science, Tokyo.
Hello, good evening, everyone. My name is Daisuke Matsura from Institute of Science Tokyo. I'm very thankful for the kind introduction of Professor Beppe Coria. And it is my surprise that when I remember when I met with Beppe Sensei first time, it was not so long time ago, just maybe 3 or 4 years. And since then, we achieved a lot of joint works. And it is my pleasure to introduce some of them here. It is my great honor again. So today's our talk is about this. It's a joint research on the development of human care robotics. We are facing to a big challenge, aging societies. The aging society is a source of new problems as reduced workforce, lower economic growth, and increased burden on public. Okay, here. Okay, sorry. Increased burden on public finances. So maybe I should use a laser pointer. Okay. Okay, thank you. Thank you. Should be okay. Okay. So increased burden on public finances and national healthcare system. Our labs developed human care solution to bring a better lifestyle to the users and an easier workflow onto the caregivers. So here is the framework of the human-centered healthcare robotics. The means of human-centered is an innovative approach to develop healthcare robotics. And our aim is designing a robot taking care of the user's feelings and comfort, developing the project with the most updated technologies. And investigated research fields are rehabilitation and assistive robotics. This figure shows the very, let's say, global framework of our project. Empathy, sophisticated design, feasible technology, and on top of that, people should be located in center. So let's say from the idea of think globally and act locally, we should specify our research field. So especially we are doing on our project on assistive robotics. Its meaning is extending users' capabilities, ensuring higher quality of life and independence in everyday tasks. That is very important to be achieved. The purpose is, of our research is reaching an optimum degree of independence to improve the user's life condition. And challenges, technical challenges, is enable custom assistance, exploiting the adaptability design of the assistive robotics. So we have two seed technologies here. One is the omnidirectional assistive wheelchair developed in the Pepe Sensei's laboratory. So I'd like to show you some video here. You can see there is a chair on top of a moving platform. This platform having the two active casters, in front and backward, and two passive casters in the left and right side. So those two passive casters are just like ones used in the shopping cart. And the active casters in front and backward can actively drive the platform. So thanks to this feature, the mobile platform is capable of achieving the omnidirectional movement, like changing its heading, let's say, angle while moving in horizontal plane. So the rider is able to move around the ordinary room like this, and also there is a haptic handle on backside, so the caregiver can easily move the wheelchair thanks to the assistance of the active casters. So this is one seed technology. And the other is the one developed in my laboratory. I call this concept robotization of things for assistive robotics. So here, again, showing some video. In this case, this platform has 4 active casters, just like a shopping cart. And there is one active caster in center. And here is just a human, let's say, pushing the cart. So thanks to the active caster's effort, the human, let's say, worker pushing the cart can easily maneuver, achieve the maneuver like this. I know that this room was, let's say, rearranged so that those two big objects were moved from center to this side. So this kind of, let's say, arrangement of the object needs a lot of human effort. But if you have this kind of active caster, very smart one with haptic sensation, very few people can move very large objects very effectively. So in order to achieve this objective, I developed this prototype active caster having 3 DOFs. One is a swivel, one is traction, and the other is up and down. So using this prototype, I attempted some experiments. One is this, side-by-side following of a moving platform beside the human. So this platform is completely autonomous, having the rider and, let's say, let's say, some mass camera on top of it. So thanks to the visual sensation of those sensors, this mobile platform can autonomously follow this human by, let's say, 1 or 2 meters distance. And the other one is gap climbing, let's say, of conventional dolly, manual dolly. So this person behind is just pushing a cart, and this is an active caster. And when this caster notified that this dolly stacking at the gap, it autonomously raises its height. So the front caster can climb up the step, and then the human behind is just push. So he can very easily climb up the gap thanks to the assistance of the active caster. So from this kind of seed technologies, we developed a new prototype, e-wheelchair having hands-free human-machine interface using the visual sensation. So Mr. Lorenzo Baieri, stayed in my lab for, let's say, more than, let's say, close to 2 years, and developed this all prototype from scratch, including hardware and software. And there are 2 frontal cameras, and looking at his face. So AI-based visual analysis can measure the rider's face orientation and position. So when you move your head, the wheelchair follows your, let's say, intention. So your hands are completely free, so you can do something while moving. So this is a very nice solution, I think. And also I tried to use this, and without taking a long time for practicing, I could successfully drive the wheelchair. So this kind of assistive technology has been developed in our collaboration. So I'd like to give the talk to Dr. Andrea Botta.
Thank you much, Rosensei. The second part of the presentation is about the collaboration still with Institute of Science Tokyo, but another lab with the head is Takeda Sensei. And the main topic is rehabilitation done with robotics. So the idea is to use robots to make the user keep repeating a motion that the doctor or the medical staff decide. So it's possible to aid both the patient to keep a consistent motion for a longer time, but also to, how can I say, supply the lack of medical staff, since both the population is aging very fast, but also there is a very large lack of medical staff. So we try to achieve both results at the same time. And the idea is to use exactly robot, because they are very good to repeating the same motion or a set of motion throughout time. And also this enables some new technique, since we can collect a lot of data. We do some, let's say, data-driven approach to medicine. And also some people start trying to do some telemedicine. So you don't need to have the doctor and the person needing the rehabilitation in the same place, but this can be happen in separate places. So among this very huge topic about rehabilitation, we start about rehabilitation about the wrist. And this was the first prototype made in Takeda Sensei lab. And the idea was to start with a quite common industrial robot architecture that we decide to wear as an exoskeleton. So now you can see just the robot by itself, but in a moment in the video you can see a person wearing like a sort of exoskeleton. Technically it's not an exoskeleton, but you can call it like this. And the motor you see now moving are driving the motion of the hand. So you can achieve this kind of motion just using the linear actuator, and at the end you can see another motion that let the user move, rotate the forearm. So it's not only about the two motion of the hand, but also the forearm. Then we start trying something more lightweight, and this was done during my postdoc period in Tokyo. I spent 8 months again in Takeda Sensei lab. And this concept is quite similar to the previous one, but we decided to substitute the electric motor with cables. So the idea was to achieve a much, much lighter device, because the idea is you have to wear this device for a longer time. The idea is to improve the feeling of comfort from the user. So our idea is to promote human-friendly design, human-centered design, as Professor Matsuura told you before. And now we are working in an even more improved solution. And so our trend is trying to minimize even more the impact of the device. These are very, very early concepts, so they are not complete design, but the idea here is to move from rehabilitation devices, so a device that is repeating some set of movement, to assisted device. So the idea is that the user is wearing these devices the whole day during its daily task, and to improve the strength or the mobility of the person. So in general, as you can see in these slides, you can see our collaboration between Tokyo, Institute of Science Tokyo, and Politecnico for our site about robotics is mostly about this human-centered design. So we desire to achieve something that's useful for human, in particular about rehabilitation of assistive devices. Here we show you about mobility and the breast, but the same topic can be used in general for different concepts, and we are still planning some future development together, so it's not just the past. As I told you before, we plan to do an assist device for the wrist, so that's the natural evolution of that. About the wheelchair in general, about the mobility devices, we share a common interest in sit-to-stand devices, so we also try to develop some systems that help elderly people mostly to stand up from the seated position, so also caregiver can have a life easier to lift that kind of person. And Matsuura Sensei is working on a new type of control-based, let's say, attention-based control. So when the caregiver is not so focused in the driving the wheelchair, let's say, the wheelchair corrects the drive. So safety is our priority since we are working with person, and that's what matters. So we really hope that what we do in some way can impact their life in a positive way. And that's it. Thank you for your attention.
Thank you so much, and let's move to the third presentation that will be provided by Professor Fantilli and Professor Nishiwaki. The floor is yours.
Thank you very much, Professor Quaglia, for introducing us and for giving us the possibility of talking about our joint research. We will talk about superconcrete for the future of construction. I'm Alessandro Fantilli from Politecnico di Torino, the Department of Structural, Building and Geotechnical Engineering.
Yes, and I'm Tomoya Nishiwaki from Tohoku University, Department of Building, Architecture and Building Science.
Okay, this is the outline of our presentation. We talk about concrete. Concrete is the most used construction material, and here you have a very nice representation of concrete structure, the dome of Pantheon. So we have been using concrete for more than 2,000 years. So we will talk about the concrete. We will show you what the concrete is, how the concrete is popular. Unfortunately, we will talk also the environmental impact, the huge environmental impact of concrete, and how we can solve this problem with the sustainable concrete. And then we will show you some conclusion and also future work that we would like to do again. So, it is difficult to talk about concrete if you have never seen it, or produced it. So the best way to talk about concrete is to compare concrete with the preparation of a cake. Concrete and cake have more or less the same procedure for the preparation. So the final result, or in the case of concrete, of cake, the final test, depend on the quality of ingredients, the quantity of ingredients, the mixing, the way we mix them, the appropriate curing in the case of concrete, and of course, the appropriate cooking in the case of cake. So let's see the recipe that we need for preparing a cake. In this case, you know we need fat milk, flour, sugar, eggs, and baking powder.
So as you can see, the concrete also requires a recipe, so like a cake. So the concrete also requires a specific amount of the cement and water and aggregate. So the aggregate is a stone and sand, so play a role of the skeletons. And these skeletons can be combined using the glues come from the cement and water. So quality of the concrete, like taste of the cake, depend on the recipe and the ingredients of the concrete.
So the preparation in both the cases is practically similar. In the cake, we have to mix the ingredients, and also in the case of concrete. Then after mixing, we have to transport what we have mixed, in the case of cake in a oven, and in the case of concrete in the place where we would like to cast and curing the concrete elements on the concrete structure. So these three main steps are the same.
So, and like cake, so concrete is a very popular material. So that's why the reason, one of the reasons is a very easy to use, like a cake. So just mixing the raw materials. So this, and the very means popular from the, not dog, cat, cat house, from the cat house, small cat house to the biggest concrete structure like a bridge. In this sense, so the production of the concrete is a very huge, 30 billion tons. That is most used manufactured material, second most after the water.
So this popularity of concrete as a problem, create a problem. And this is a typical problem of mass productions. So we have a huge environmental impact of concrete. Anyway, you can see here, if you see, sorry.
Here does not show the,
okay. So you can see here the comparison between cake and ton. For producing a ton of cake, it takes about 0.3 tons of CO2, lower than the production of concrete. But if you see the consumption of concrete is more than 1,000 times higher than the consumption of the cake. As a result, also the carbon footprint of concrete is 1,000 times higher than the carbon footprint of cake. And this huge production of CO2 make the concrete one of the most impactful material in the world. If you see here, about 80% of the world's total CO2 emission is due to the production of concrete. So, as we want to save the planet, we need superpowers, like a superhero. And our common research is to, let's say, unlock these superpowers in the concrete. In particular, we want to have super strong concrete, so with a super strength. And for this reason, we worked, and we are working still now, on ultra-high performance concrete, UHPC. We would like to have a super tough concrete that can bend without breaking. And this is the case of fiber reinforced concrete. We need also the capability of heal itself. So we have self-healing concrete. And also we need a printable concrete in order to digitalize the construction of or the preparation of concrete structures. So let's see these four we call superpowers. The first one is a super strong concrete, UHPC. As we need a recipe for producing concrete, if we change the quantity and the quality of materials, we can have a different result. And in particular, we changed the composition of concrete in order to increase the strength. And we can move from the normal strength concrete, about 30 megapascal of strength in compression, to more than 200 megapascal UHPC. As you can see in this slide, when we move from the normal strength concrete to ultra-high strength concrete, of course, we have a more impactful material, but as in the case of cake, if we use less material, the global emission of CO2 is reduced. So with super strong material, we use less material.
Okay, so let's move to the super tough material, super tough concrete. So if concrete is fiber reinforced, we have, as you can see, basically the concrete is a very brittle material. As you can see on the top movie. On the other hand, so you can see the bottom movie, so that this superpower fiber reinforced concrete can have high ductility, so more bendable structures. So the capability of this kind of bendable material, so that to achieve the capability of absorbing a lot of energies means better resistance against the earthquake, especially the earthquake-prone area like Italy or Japan. So, and also this kind of resilient structure can provide the longer lifetime. It means global CO2 emission can be reduced. And next is a self-healing concrete. As you can see, we human, sometimes we have to go to the hospital, but basically we can take a rest and full recovery. Like this, concrete, if the concrete has a self-healing potential, so we can skip the costly diagnosis and repair material, maintenance work by the constructors, construction engineers or something. So as you can see on the bottom photos, so of course this concrete requires a special ingredient. In this case, the fiber, specific reinforcing fiber using PBA or something. Another approach is some bacteria can be installed, or SAP, the super absorbent polymer, is another approach. But anyway, so this kind of self-healing concrete can achieve the reduction of the CO2. Finally, this is a printable concrete. So nowadays, the concrete 3D printing drastically developing all over the world. So as you can see, this 3D printing can achieve the free form without any mold. So on the other hand, to just put the concrete is we cannot to provide install the reinforcing material inside. Anyway, so this 3D printing can digitalize the construction process, and the structure can be optimized because of the absence of the formwork, and so we can also reduce the material employed material, so that it can contribute to the more sustainable aspect.
Okay, so to conclude, as you can see in this picture, we are in the world of concrete. There are many concrete structures that we use every day. And if we can, let's say, unlock the so-called superpower of this concrete, we can contribute to the sustainability, to the reduction of the 8% of CO2 released in the atmosphere every year by concrete. We can do this because we can use less material and so less natural resources. We can build more resilient and longer life structures, and we can have also the possibility of building smart constructions. So, as a future work, Politecnico di Torino and Tokyo University are going to unlock another superpower, the possibility of increasing the circularity of concrete. In this project we are developing, we do not only apply the three that traditional are: reduce, reuse, and recycle, but 10 R's in all the stages of constructions. So, in other words, we believe in another superpower, reincarnation. So, thank you very much for your attention. Grazie per la vostra attenzione.
ご清聴ありがとうございました。So this is based on the long collaboration.
Okay, thank you.
So thank you very much. Your presentation was really curious, and we are waiting the new cakes that are coming from your research activity. So the last presentation will be provided by Giovanna Panic and Professor Adachi.
All right, thank you for having me, and I was very happy to skip a long waiting line for Italian pavilion. All right, I am Hideaki Hayashi, Associate Professor from D3 Center at University of Osaka, and we have another speaker, Dr. Giovanna Panic. She's also from the University of Osaka. So, to be honest, we have just started the discussion towards the collaboration between Osaka and POLITO. So to be honest, we don't have a result yet. So today we will talk about mainly focusing on our research activity, including computer vision and machine learning in medicine. And then we discuss the possibility of the collaboration between Osaka and POLITO later. So again, let me introduce ourselves. The right side, my name is Hayashi, Associate Professor from D3 Center of Osaka University. I was originally from Hiroshima Prefecture, and then I was working as Assistant Professor in Kyushu University for about 5 years, and then I am working as an Associate Professor in Osaka University from 2022. And then the left side, Dr. Giovanna Panik is a postdoc researcher in Osaka University. She's working on one of the biggest project, biomedical engineering project, which is called WPI Prime. And she is originally from Serbia, and she grew up in Italy, and then she got a bachelor's degree, master's degree, and a PhD degrees in Italy, POLITO. And then she moved to Osaka in 2024 and now working as a postdoc. Then we are the same laboratory called IS Lab. We are mainly focusing on machine learning, computer vision, and natural language processing. I think our laboratory is kind of biggest laboratory in the D3 Center because we have 6 faculty members, 2 postdocs, 9 PhD students, and 15 master's and bachelor students, and 6 internship students. And one of interesting point of our laboratory is we have our members, 60% of our members are from overseas. So we are open to international collaborations. So our mission, given from the university, is interdisciplinary research using information science and technology. So we have a lot of collaboration with interdisciplinary departments like medical department, dental department, and social science departments. So today we're gonna focus on collaboration in the medical fields. We also have a lot of collaboration in medical fields, medical researchers, including biosignal analysis, endoscopy image analysis, infant video analysis, and teeth data analysis. So I'm going to talk about some topics from this list. So first topic is about infant video analysis. Our target is movement called general movements. So a general movement is spontaneous movements of infant, which happens around 20 weeks of age. So every baby shows these movements. And this movement is very useful for early detection of nervous system diseases because this movement is strongly related to nervous system diseases. So these movements can be classified into some types, like rising movements featured by upper limb movements, and fidgety movements featured by lower limb movements, and cramped synchronized movement, which is kind of rigid movement, and monotonous movement, which is called a poor repertoire. And the rising and fidgety movements are kind of a typical development movements. So every kind of healthy baby shows this kind of movements. And the latter half of movements, cramped synchronized movement or poor repertoire movements, are related to nervous system diseases. So by analyzing this these movements, we can detect diseases in early stages. So we have developed the system for general movements classification. In this system, we capture the movements of the video from the camera above the baby, and then we extract the features of upper limb movement and the lower limb movements. And then we classify the movements using a neural network into some categories to detect the nervous disease in early stages. So one of difficult points of this project is how to collect data. So to collect many data, we should capture a lot of babies' video. So to increase N by one human should be born. So how to do that? To increase N, I used my son. So I measured my baby's video once a week by around 20 weeks of age, so we can see the development of my son. So cute, right? Then, but the difficult point, sorry, what? The power is out.
The computer is shut down.
Power is running out.
Very cute though.
充電がもう完全に切れてるっぽいですね。
Baby was consuming too much energy.
Too much movement.
Sorry for this few seconds. I think we will start again. We can use this few seconds of waiting to make some comments on what was happening right now. You have seen that there are professors that are coming from different environment, research environment, different topics, and also different universities. Okay. Okay, maybe they will switch the computer. But the message is we are open for collaboration in different fields, not only the ones that you have seen today, but in new fields that you can suggest us. It is really easy to interact each other, and also it is really easy to get new ideas from this fruitful environment. Okay, I will leave the floor to you again.
You have the presentation?
Number 4, Panic.
In the USB?
Do you have?
Ah.
Okay, open it back up. Okay, go back where you were. Ok. Ci siamo? Se voi ci siete.
Shall we? Okay.
Please enjoy my baby. All right. So one of the difficult points in this measurement is the measurement is not like a textbook. So medical paper says general movements can be observed in a good mood after bathing, but reality doesn't go well. And when I started the video, and then he started crying, the video stopped. And then after restarting the video, and he threw up the milk, the video stopped. So this is one of the difficulty in a real-world application of machine learning. All right, let's switch.
Thank you so much. From videos to medical images, like the classical medical images. Here in this case, I will present the research that I carried out with, in collaboration with the Polytechnic of Torino. And as Hayashi-sensei mentioned before, I'm a biomedical engineer, so during this research, we were trying to focus mostly on not just to develop a general system able to support the clinician by automatically detecting the rectal cancer and characterizing it, but also to focus on how to identify the best ways to solve three main issues. The first one, how to properly manage the medical data. Then, of course, how to properly develop a deep learning and a machine learning system to be able then to actually be introduced in clinical practice to allow clinicians to feel comfortable into using these kind of things, and also to allow the patients to be fully knowledge on what's going on during the visit. So, for what concerns the first question, like the medical data, here are some examples of abdominal MRIs. From your perspective, maybe they are not so different, but there are some like variabilities that as technicians, let's say, we have to deal with. Not just the biological differences, because as you know, like especially in the abdominal area, differences between gender, between height and weight actually affect the images, but also technical issues. In this case, we have different fields of view, so a different amount of organs and tissues that are inserted into the image. And of course, since there are no standards into medical data acquisition, all these images present a different resolution, different intensities, and so on. So the first question that we as computer scientists, biomedical engineers, we have to solve is how to properly manage those data to maintain the clinical validity of those images and also to allow them to develop a robust artificial intelligence system. So after a deep analysis of the literature and also on our study cases that we had, we were able to develop a robust preprocessing able to reduce the technical variability, maintaining still the clinical validity of the information within the image, and maintaining that the one that is the biological variability, since thanks to the collaboration with clinicians, we found out that it's extremely crucial to maintain within the image. Once obtained those processed images, we started to develop a deep learning system for the automatic detection of rectal cancer. And we didn't just focus on getting the best performances, but we also wanted to analyze how to properly develop such systems, so also investigating different structures, different hyperparameters related to the deep learning system to obtain a model able to detect automatically and segment properly the rectal cancer with a high accuracy, considering also the clinician, let's say, annotation given for this study. And in order to move one step forward to actually support the clinician for the definition of the best therapy for the patient, we develop a machine learning system able to extract information, morphological information from the images, from those yellow areas, in this case, from the rectal cancer, to identify the patients that would, more probably, obtain a good response to the neoadjuvant chemoradiotherapy. So, thanks to this automatic system, we were able to obtain a model that was able to identify the patients that were highly suggested to undergo the neoadjuvant chemoradiotherapy. In this case, the patients identified with the green light, while the other patients whose response was probably not so good, we were able to suggest to go under surgery, so to avoid all the drawbacks caused by the neoadjuvant chemoradiotherapy. So creating in this way, developing a system able to support the clinician and to move towards more personalized treatment for the rectal cancer. Given all the studies that we carried and the publication and the issues that we noticed during the development of such system, we gained enough knowledge to actually identify some common, let's say, questions that should be made when we deal with the human body and the medical images. And since I joined the IZ Lab and the WP project, I tried to maintain the same, let's say, focus and trying to be able to develop a system that it's not just technically advanced, but also to be able to truly support the patients and the clinician using the retinal fundus images, in this case, so changing completely the body part of the people, maintaining the idea that once Shakespeare told that the eyes were the windows of the soul, now scientists can say that the eyes are the windows to the body, because thanks to the eye, especially thanks to the retinal fundus images, it is possible to extract information related to the neurological, cardiovascular, and diabetes. So we are now trying to develop a prediction model able to identify different biomarkers starting from the same image, able to be reliable to identify and to predict the presence of the pathology. And thanks to the study that we are now doing with the hospital within the Osaka University, we are trying also to follow the health history of the patients through 10 years. And we are now working on the development of a model able to predict the onset of the disease before it happens, in order to also provide some support to slow these kind of diseases, to allow better, let's say, a better life to the patients, in this case to avoid the sight loss. And here the Polytechnic of Torino is actually supporting us with this newly started collaboration with the bioengineering department. And we are extremely we think that thanks to this collaboration, it will be possible to merge our knowledge in machine learning and in biomedical engineering and collecting all the clinical data to enhance the interpretability of artificial intelligence systems in medicine, enhance also robustness and reliability, and at the end, introduce more interdisciplinary collaborations to allow the merge and to unify the different knowledges to support the patients. And our, let's say, main goal as a researcher and our thoughts that are driving us is that thanks to this combination, thanks to the integration of different knowledges and different techniques, it is possible actually to support the human beings in the future. And thank you so much for your attention again, and despite all the technical issues. Thank you.
So I really want to thank all the speakers, because it was a challenge to provide so wide approach, so wide sort of example. We move from machine learning, AI, chemistry, energy, concrete, robotics. So, and the idea, as I mentioned before, was to prove that it is possible to collaborate. Now in the future we have many opportunities also to participate in competitive CAL at European level. For example, Horizon are just there in order to support collaboration between Italy and Japan, GSPS, and many other opportunities are there. So from this small workshop, I hope that you will bring at home the idea that it is interesting to collaborate together to get results and to provide dissemination of the results. If you have any question, this is the time to do this. And so I don't know if there are questions that are related to the research activity. And so if you raise up your hand, we can call the proper speaker according to the question that you have. I can understand that it is not easy to make a question and answer session after this so wide talk this afternoon. But we are also a group of friends. We know each other. Most of you are well-known researchers, and also some new members of the group are coming. So if someone has some comments in general, some proposal or something that can be said, again, you are most than welcome. Okay, so this was a bit too topic, but really I know that there are, okay, sorry, there was a sort of, please, you can, there is a microphone over there.
Yes,
Sorry.
I'm Tomoki Noda from ATR. So ATR is a kind of research institute. So we also have been collaborating with worldwide, and also that we are accepting many international internship students. Also from Japan, we have many collaboration as an internship student from the university. So actually such kind of so this workshop is one of the most surprisingly nice presentation, because the two faculty PI member presenting together, that was amazing. This is the complementary. This is one of the very surprising design, and I really liked it. But in my institute, actually, our research funding is mostly outsourcing. So actually, I don't really complain, but ATR doesn't pay any money for research. So I really need to get funding, including my salary, from the outside funding. So the question here is, that collaboration was very much surprising. It was very nice, and it's very challenging researches. But my question is, how that three presenter managing the funding resources to hiring the people, and maybe going back Italy to Japan. I think it's cost a lot. Mm-hmm. So my question is how they manage research funding to continue the collaboration. So is that possible for knowing how they successfully manage such a nice collaboration?
Okay, thank you for the question. I can give you, let's say, a general answer that is related to some opportunity that I know. One is that each partner has its own funding. So they try to work together mainly, but using their own funding that enables some mobility or some lab activity and so on. But now we have to make another step, is not to participate to competitive call together in order to get funding to support the research. And as I mentioned before, Horizon is something that can be used. We have to enter more deeply in the schemes and the opportunities that are provided by Japan Founding Agency, and that's my side. I don't know if some of the speaker has something to add.
Hello. So in my case, I didn't obtain any financial new support from the joint. In our case, the joint is done mainly to enhance the research, which is partially already begun in each of our sites, and we joined our research together to produce something new. And the other thing is education. So we wanted to supervise a PhD candidate together. So that was another meaning of the joint. So of course, in future, we'd like to apply to new financial support in Horizon or JSPS, but we have not done yet. So that is my answer. Thank you.
Are there more words from the speaker or not? If not, sorry, because the light is not enabling me to see if someone raise up the hand. Seems no. If no, again, once more, I want to thank all of you a lot of you moved from different places, different cities, and so thanks for coming. And now there is the most important part of the evening, so we have a small appetizer that will be provided, so we can enjoy some time together. And just behind you, you will find this appetizer. Few minutes, they told me. So thanks again, and that's all for this evening.